Arc length and curvature. This theorem says the plane curve given a smooth curve C defined by the function RT equals FTI plus GTJ, where T lies in the interval A to B, closed interval. The arc length of C over the interval is, the S represents the arc length, and that equals this integral of the square root of those two squared and square rooted, which is essentially the magnitude of r prime t dt. The space curve gives a smooth curve C defined by the function r equaling ft gt ht, and where t lies within the interval, the closed interval ab, and the arc length of C over the interval is the prime squared g prime squared h prime squared square rooted, which essentially is magnitude of r prime t dt. So that's all we really have to remember from this formula, is I'm taking the integral of the magnitude of r prime t dt. And that's it. So it doesn't matter if I'm two-dimensional or three-dimensional. So let's just take a look at this problem below. It says find the arc length of RT equaling 2 sine t, 5t, 2 cos t for t from 0 to pi. Okay, what we're going to do is we're just going to set this up. And these are pretty straightforward. Just follow the formula. So this is going to go from 0 to pi. And I'm going to have to take the derivative of RT first. So I don't want to write anything there yet. I'm just going to come over here and find r prime t. And for the first one, it would be 2 cos t. For the second one, it would just be 5. And for the third one, it would be negative 2 sine t. There we go. Now what we need to do is take the magnitude of this, because that's the formula. So square root, and remember the magnitude is taking each of those and squaring them and adding them together. So this is going to be 4 cosine squared t plus 25 plus 4 sine squared t. Kind of skipped a step. Hopefully you're okay with that. And then this can be simplified even more. Take a look at this. I can put my 4 cosine squared t plus my 4 sine squared t plus 25 on the end. So here I can factor 4 out. Now watch this. Square root of 4. I'm going to have cos squared t plus sine squared t and then plus 25. I didn't do anything with that piece at all. I'm just going along for the ride. So now cosine squared t plus sine squared t equals 1. So this is actually going to be 4 times 1, which is just 4. So this is square root of 4 plus 25, which is equal to square root of 29. So the integral from 0 to pi of square root of 29 dt equals square root of 29t from 0 to pi. Now the 0 is just going to give me 0, so really I just have the square root of 29 pi. So there's the answer.